of the most important sections as far as vocabulary because it's going to come up often. We're going to talk about certain kinds of angles today. We're going to talk about adjacent angles, vertical angles. By the way, I need to mention this because I did not tell you to begin with. In pre-AP geometry, I will start counting off for spelling, writing incomplete sentences, capitalization at the beginning of your sentence, punctuation at the end of your sentence. So on the first couple homework assignments, I may have circled something and put SP. That means you've spelled it wrong. I typically will count off more on the test and then give you time to practice on the homework. So if I notice you're spelling something wrong on the homework, I may not count off points. I may just circle it, and then that gives you some feedback so that hopefully it won't cost you points once you get to the test. So spelling, capitalization, punctuation, I'll look for it on your homework, but then I may not actually take off points until you get to the test, okay? Just so that you'll learn and get better at it. But you need to practice your writing abilities in math as well, and we'll be writing incomplete sentences. One of the most common misspelled words in here is vertical. It is A-L, not L-E. And a lot of students will put L-E instead of A-L. So be really careful. Complementary and supplementary. And I think you probably have learned all of those words at some point in the past. I remember when my kids were younger, back in middle school, maybe sometime, they made like a flip chart and they learned all of those words. But we'll see if you know them or not. A little less vocabulary in this section today. All right, so we're going to start with adjacent angles. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. When you think of adjacent, what do you think of? Say it again, Liam. Next to each other. When I think of adjacent, I think of two things that are side by side. If you look at angles 1 and 2, would you agree that they are adjacent or touching side by side? Okay, so first of all, they have to be in the same plane. They have to have a common vertex. So they do have a common vertex here, angle 1 and 2. They have to have a common side. They do have a common side here. This ray in the middle is the same for both angles. But they can't have any common interior points, and that's the kicker there. Oops, sorry, I forgot to change that this morning before we started. Bear with me 1 minute. If anybody knows anything about PowerPoint and knows how I can make this change all the time, let me know. Okay, should work now, we'll see. Okay, so if I pick points inside angle 1, are any of those points inside angle 2? No. These points are only inside angle 1. These points are only inside angle 2. Let me give you an example. That's not adjacent. And that's distracting, I'm sorry. Okay, so here's angle 1, here's angle 2, here is angle 3. Okay, angle 3 is the great big angle. If I look at angle 1, and I look at angle 3, would angle 1 and angle 3 be adjacent? No, because they have common interior points. They do have a common vertex, would you agree? And they also share a common side here. But if I pick a point inside angle 1, it is also inside angle 3. So when you think of adjacent, they cannot overlap. And when I look at these two angles, I see overlapping angles. So they have to be touching, they have to have a common vertex, they have to have a common side. I'll give you one more example. Are angles 1 and angle 3 adjacent? Do they have a common vertex? Yes. Do they have a common side? Draw angle 1. Use a pink marker. Now I'm going to draw angle 3 and use a red marker. Do they have common sides? Nope. When I drew this line, this ray and this ray, that is not the same ray as this ray or this ray. A side of an angle, remember, is a ray. My marker would have to trace it if they had the same side. These are the sides for angle 3. These are the sides for angle 1. They do not share a common side. They do share a common vertex, but they don't share a common side. So these are not adjacent. Just because they touch at a common point doesn't make them adjacent. The entire side of the ray has to touch the other entire side of the ray. Okay? So we're going to practice in just a second. I don't know if that was my phone or your phone, but just a reminder that your phone should be shut off. It was probably mine. So that's a note to myself. Okay. Linear pairs. Look at a linear pair, first of all, up here on the board, 3 and 4. Are 3 and 4 adjacent? Yes, they have a common vertex, and they have this common side. And no points inside 3 are also inside 4, so they don't share any common points other than the ones that are on the side. So a linear pair, first of all, has to be adjacent. Okay, what word do you notice is inside the word linear? Line. Okay, there is pair, but that's not inside the word linear, right? Just inside the word linear is the word line. So when you have a linear pair, you're going to have a pair. First of all, how many is in a pair? 2. So it's got to be 2, no more than 2. You're going to have a pair of angles. They have to be adjacent, and they're going to form a line. Okay? So I'm going to go back to this picture over here on the board. Is this a picture of a linear pair? How many angles are in this picture? 3. Is that a pair? No, there's actually 4 in the picture, but 3 individual angles, right? And then 1 great big angle. It takes all, actually there's more. There's 6, 1, 2, 3, 4, 5, 6. Is that correct? So 1, 2, 3, 4, 5, 6, right? I think there's just 6. Okay. Okay. Back to the idea of a linear pair, though, here real quick, okay? It takes all 3 of these angles to make the 180-degree angle. If I take out angle 2, these 2 angles are not going to add to be 180. I need this angle in there. So this is not a linear pair because it's not 2 angles. It's not a pair. Has to be a pair, has to form a line. Has to be adjacent. So let's look at this example. Tell whether the angles are only adjacent and form a linear pair, or they're not adjacent at all. So we're looking at this picture, AEB and BED. Take a minute, make your decision. Are they adjacent and they form a linear pair, or not adjacent at all? You decide. Lucas, what do you think? Just adjacent? Okay, so if I trace AEB, I'm talking about this angle right here. Let's see if I can change my color. Now I'm going to trace the other one, BED. That's talking about this angle right here. I would agree they are adjacent, but when you put them side by side, do they form this straight line? If I draw the red one, I'm going to draw it in blue here, and then I draw the other one. Together, those are forming a straight line. So they should be adjacent and form a linear pair. Let's try another one. Go ahead and see if you can try the next 2 at the top of your notes. Go left to right, do the next 2, make your decision, and then we'll check them. And if you're having trouble, redraw them. Draw the one it says, then draw the next one it says, and see. Are they adjacent? Are they adjacent and forming a straight line? or are they not adjacent at all? All right, let's go with, don't tell me because it's right on the tip of my tongue. I don't know why it starts with a C. Okay, tell me. I don't know that that helped me at all. Canyon. Thank you. Canyon cross. All right, Canyon, I'm so sorry. Canyon, adjacent, adjacent and form a linear pair or not adjacent at all? Okay, he says only adjacent. So AEB and BEC. So I would agree they share a common vertex, they share a common side, they're not overlapping, but they don't form a straight line by themselves. They look like this when I put them together by themselves. So it's only adjacent. Very good, Canyon. Let's try the next one, and let's go with, I'm going to cheat. I don't like not knowing, but I still haven't learned. Okay, Remy. Adjacent, adjacent and form a linear pair or not adjacent at all? Okay, Remy says adjacent forms a linear pair. Let's see, DEC, that's this angle here, and AEB. That's this angle here. So do they share a common vertex? Yes. Do they share a common side? No. If you look, the angle on the right has 2 red rays, the angle on the left has 2 blue rays, and they don't overlap. To form a linear pair, they have to be adjacent. They have to share a common side. There's a missing angle here in the middle, so they're not touching side by side. So these would be not adjacent. Questions? Okay, so 2 vocabulary words and 1 for you have to understand that are super important. Adjacent and linear pair. By the way, what's a linear pair always going to add to equal? 180 degrees. So like the homework question you guys had last night, when you were doing part plus part plus part equals the whole, if I have a linear pair, so if I were to take out one of these here, part plus part should equal the whole, and the whole would be how many degrees? 180. Okay, so every time you have a linear pair, it's going to add to be 180. Okay, let's talk about complementary versus supplementary. Complementary is also going to be only 2 angles. Supplementary is only 2 angles. If it takes more than 2 or less than 2, we don't call them complementary or supplementary. So today's lesson is all about pairs, okay? Complementary and supplementary. Complementary is 2 angles that sum to 90. What does sum mean? Add. So if the 2 angles add to be 90 degrees, we call them complementary. Supplementary, they sum to be 180. So if they add to be 180 degrees, we call them supplementary. So what word have we learned today, or what example of angles would also be supplementary? Very good, a linear pair, because it's 2 angles, and when we add them together, they form a straight line, which is 180 degrees. So every linear pair is also going to be supplementary. It's going to be adjacent, it's going to be supplementary, but we're going to call it a linear pair because that's more specific. Okay? So, little trick if you get these confused that's in the textbook when you finally get it, is if you're having trouble, remember that in the alphabet, C comes before S. And on the number line, 90 comes before 180. So if that helps you kind of keep it straight, which one's which. Okay? Bless you. So if I look at the picture here, which angles would be complementary? B and A, 53 and 37 adds to be 90. Are A and B adjacent? Right now on the board, are they adjacent? No, they are not touching. They do not have a common vertex. They are not sharing a common side. Yes. I forget every day. So glad they come on and remind me. Sorry. Talk amongst yourselves for just a second. Where's it at? And 27. Okay, sorry, back up here. Guys, back with me, please. All right, so A and B, those are going to be complementary, but what I wanted to point out is to be complementary, you do not have to be adjacent, okay? Which two angles would be supplementary? A and C. So if I look at A and C, these two, those would be supplementary because they add to be 180. Are they adjacent? Think about it, Yi. What does adjacent mean? They have to be touching. Are A and C touching? Okay, but a linear pair has to be adjacent. It has to form a line. These two angles aren't even touching each other, so they're not forming a line. They do add to be 180, but that doesn't make them a linear pair, and that doesn't make them adjacent. That makes them supplementary. Okay, so I want to make sure you're clear. Kenyon? That's just the definition of a linear pair. It is two angles that have to touch and form a straight line. Okay? So make sure you're with me here. A linear pair is two angles that touch, share a common vertex, share a common side, and form a straight line. Are they adjacent? Yes. Are they supplementary? Yes. But you don't have to be adjacent to be supplementary. They do not have to be adjacent to be supplementary. They do not have to be adjacent to be complementary. But to be a linear pair, they have to be adjacent and they have to be supplementary. Is that making more sense? Okay. To be complementary, they don't have to be adjacent at all, but they could be. Would those two angles be complementary? Yes, they are adding together to form a right angle, so therefore they're adding to be 90 degrees. Is this an example of complementary angles? No, because there's not two, there's just one angle. Complementary and supplementary has to be two angles. They don't have to be adjacent, but to be a linear pair, they do. Okay? All right. So now we're going to talk about the words complement and supplement. And this is where it can get a little bit confusing on the harder application word problems. So I want to make sure you understand the difference between complementary and complement. Those are two different things. Complementary means two angles that add to equal 90 degrees. By the way, this is how you can write angles, and you can always use symbols in this class. So normally I make you write things out. I won't let you abbreviate, but you can use any symbol in here at any time that we learn a symbol. So you just have a little angle and then an apostrophe S. And the book sometimes will write it like this. And students get confused about what they're doing. That's their way of saying angles in the book. So apostrophe S, though, is how we usually write it. Okay. Complementary, two angles that add equal 90 degrees. The complement is one angle. One angle. The complement is 90 minus the angle. And I don't like that they put X there because then they use X's in other problems and it confuses you. So I'm just going to put 90 minus the angle. So let's say that I have a 50-degree angle. What would its complement be? 40. Very good, E. If I have a 72-degree angle, what would the complement be? 18. So the complement is the angle that you get, or the value you get when you do 90 minus a given angle. Okay? So if you're doing a word problem and you don't know what the angle is, you could use a variable to represent that unknown angle, and then the complement would be 90 minus that variable. That's why they put 90 minus x. I'm going to use the word angle just so you don't get confused with x's when the problem already has an x in it. How could it be negative? You can't have a complement if the angle is already 180, because remember, complementary are two angles that add to be 90. So in order to have a complement, the angle that you're talking about has to be less than 90, or it wouldn't have a complement. Does that make sense? Okay. So supplement, same idea. It's going to be one angle, and it's going to be 180 minus the angle. And again, I'm not going to put the 180 minus x because I think that'll mess you up on some of the homework problems. You put in whatever variable you want to represent your angle. So if I have a 100-degree angle, what's the supplement? 80, okay? So now we're going to look at some problems. And this is where I think it could mess you up with the x. So I'm just trying to help you out there. So start with something super easy here. Complement of angle F. What's the complement of angle F? 31 degrees. Because complement is 90 minus the angle. And the angle was 59 degrees. Okay, don't forget to put your degree symbol when you write your answer. Supplement of G. So what's supplement again? 180 minus the angle. Make sure you write that down or you'll get lost every time. 180 minus the angle. So now look at your picture. What's the angle? 7x plus 10. So we're going to write down 180 minus 7x plus 10. And be careful that you put that in parentheses or you're going to get the answer wrong. It is minus that whole angle, 7x plus 10. So what does this tell us to do when we put that in parentheses? Okay, what do we call that word? Distribute. So we're going to distribute the negative, which is going to change both of those signs. So now we're going to get 180 minus 7x minus 10. Can we simplify that? Good. 170 minus 7x. I heard Remy say. Is there an equal sign anywhere here? No, this is not an equation. You're not solving for x. The only way you can solve for x is if you have an equation with an equal sign. This is an expression. We're just writing an expression to represent our supplement. The angle was an expression, so the supplement's going to have to still be an expression. Does that make sense? The only thing that I would include is, remember, this is an angle, so it should be measured in degrees. So don't forget to put your little degree symbol. You should, because the degrees applies to the whole value. Any questions here? All right, let's get a little harder. So now read this problem. I'm going to give you about 2 or 3 minutes. I want you and your partner to see if you can figure out how to solve this. Feel free to talk to your partner, guys, forwards or backwards, side to side. Brainstorm if you're stuck. And I will tell you, you should be getting an actual numerical answer, not an expression. raise your hand if you think you have an answer. I'm not going to call on you and ask you what it is. So just tell me if you think you have an answer. Okay, I've got 5, 6, 7, 8 of you. Okay, so I'm going to show you the teacher algebra way that I would set it up if I were teaching Algebra 1, and a process that will work for you every single time. And then I'm going to ask you if you did it different to tell me what you did, okay? So here's how I would do it if I were working this problem. When you have a word problem and you're trying to write an equation, then you want to break it apart word by word. So an angle, I don't know what the angle is. Is in math, what does is mean? Equals. When you see is, it means equals. If I don't know what the angle is, what can I do if I don't know what something is in math? Variable. So what do you want to call it? Y, okay? So an angle, I don't know, I'm going to call it Y, is equals 10 degrees more than. So what does that tell me to do? Okay, to add 10. I'm going to add 10 to something. So I'm going to go ahead and write Y equals, and I'm going to skip some space here, and I'm going to add 10. So adding 10 to something. It's 10 degrees more than 3 times the measure of its complement. So let's stop real quick. What did we say the definition for complement is? Okay, be careful. Okay, hold on just a second. Stop. First of all, 90 degrees is not complement. What is 90 degrees? No, what is 90 degrees? A right angle, okay? Two angles that add to be 90 is not a complement. What is two angles that add to be 90? Complementary. What's the definition for just the complement? 90 minus the angle, okay? So make sure you have that down or it's going to mess you up. 90 minus the angle. What did we call the angle? Y. So what can we write here for the complement? 90 minus, what did we call the angle? Y. And it said it was 3 times the complement. So what am I going to do to this 90 minus Y? Multiply it by 3. Okay, so one way that would work every time is to dissect the sentence word by word. An angle, I don't know. Is means equals. More than means add. 3 times means multiply. Complement means 90 minus your angle. Now you have an equation and you can solve it. What's the first thing we need to do? Distribute the 3. So I have Y equals 270 minus 3Y plus 10. Now what can I do? Very good. So combine those like terms. 280 minus 3Y equals Y. Now what? Add 3Y. So now we have 4Y equals 280. Okay, divide by 4. And Y is equal to what, Malachi? 70. Now be careful. The question said, what's the measure of the complement? Is 70 degrees the measure of the complement? No, because what did we let Y be? The angle. So the complement, remember, is 90 minus the angle. So if the angle is 70, what's... Good. And you're going to explain it to me in a second. What do we call... What is the measure of the complement going to be then? 20. Okay, raise your hand now if your answer you had was 20. All right, awesome. Look how high your hands got this time. When I first said, raise your hand if you think you have an answer, it's like, and then when you realize you're right, you're like, yeah, that's me. I got it. All right, so I need just really quickly, start with Yi. Can you tell me what you did, Yi, to get yours? Sorry, coming over here. 3x plus 10 plus x equals 90. Okay, so you're using the concept of complementary, that they add to equal 90. And so Yi said, well, if one angle is 10 degrees more than 3 times the complement, he let his x be the complement. You guys with him there? And so he has his complement plus the other angle being 3 times the complement plus 10. So that gave him 4x plus 10 equals 90. Subtract 10. 4x equals 80. Divide by 4 and x is 1. It is easier. But you have to make sure you understand a way. What I will never do in here is say you have to work something my way. Okay? Never. I want you to be able to get the solution and understand how to do it. And if a different way works for you and works every time, then you are always welcome to do it your way. So that's why I wanted to see, did anybody do it a different way? How many of you who got 20 did it Yee's way? Awesome. Okay. Okay, so you need to figure out what works for you, but you need to be able to work it one way or the other. Okay, you'll have questions like this on your homework. Any questions about the difference between complement versus supplement versus complementary and supplementary? All right. I did not mean to erase this a while ago, so I'm going to fix that back. Okay. Moving on. Go ahead right here. Let's look at this one together. This is just an example of what we've already talked about. It says light passing through a fiber optic cable reflects off the walls of the cable in such a way that angle 1 is, what does this mean again? Congruent to angle 2. Notice in the picture that they went ahead and marked. Also notice that those marks are staggered. They're not making one solid curve. If you make one solid curve on an angle, then that means the whole angle. If you're trying to say they're congruent, they'll always stagger them a little bit so you can tell the difference between the whole angle or the parts. They say 1 and 3 are complementary. What does that mean about 1 and 3? Add to equal, careful. I heard two different answers, 90. 2 and 4 are complementary. So that means 2 and 4 are going to add to equal 90. Okay, so these two add to be 90, these two add to be 90, and they are adjacent, so they're actually going to together form a right angle. They tell us angle 1 is 47 degrees, and they want us to find all the other angles. So which angle automatically should we know? Angle 2. What is angle 2 going to be? 47. They were congruent, so angle 2 should be 47. Remind you that you have to put that little m in front when you're giving the measure of the angle. You're not naming it, you're telling me its measure. All right, how am I going to find angles 3 and 4? Exactly. 90 minus 47. What is 90 minus 47? 43. 43 degrees. So that means angle 3 should be 43 degrees. And since 2 was 47 also, then 4 is going to be 43 degrees. Questions about how we got those? Pretty easy, right? Okay, these problems sometimes look like they're going to be complicated and really they're not. So don't let the word part stress you out. They went about it really long, can you tell? Okay, last thing that's in section 1.4 is vertical angles. I'm going to stress and stress and stress. This is huge. Vertical angles. We are going to use them all year long. We're going to use them in proofs a bunch. You have to be able to spell it correctly. We will talk about them over and over and over again. Vertical angles are two non-adjacent angles. So they're not touching in the sense of the word adjacent. They may share a common vertex, but they're not going to share a common side. They're not adjacent. They are two non-adjacent angles that are formed by two intersecting lines. So when you draw the two intersecting lines, you want the two angles that are not touching. Those are the vertical ones. So which ones are not touching? 2 and 4 or 1 and 3. Now again, they share a common vertex, but if I look at angle 1 and I look at angle 3, they don't share a common side, right? So they're not adjacent. These are vertical. 2 and 4 are vertical. And then the textbook is not very good in the sense that they expect you to use a theorem tonight on the homework that they don't teach you in this section. So I'm going to go ahead and have you add it to your notes. So somewhere on your notes, I want you to add our very first theorem. And let me tell you what a theorem is. We said a postulate was a statement that was accepted true without what? Without proof. We just believe it to be true. Theorems are going to be things that we can prove true. And we're actually going to be proving things in here. So our very first theorem that can be proven true is called the vertical angle theorem. And again, I'm going to use the little angle theorem or angle symbol all the time because it's shorter, quicker to write, and you're welcome to use symbols in here. The other very commonly misspelled word is theorem. So make sure you can spell that word theorem. Vertical angle theorem. And here's what it says. Vertical angles are congruent. Vertical angles are congruent. Really simple. And think about it in the picture. Let's go with Lucas. Remind me who's beside you. What's your name again? Luke. Oh, that should be easy. Lucas, Luke. Luke, pick a value for angle 1. What do you want the measure of angle 1 to be in this picture? Any value you pick. 110? Okay, so if this is 110 degrees, look at the fact that 1 and 4 together are forming a straight line, right? What would that mean that the measure of angle 4 would have to be? 70 degrees. Now look at angle 4 and angle 3. Would you agree that together those form a straight line? So what does that mean angle 3 has to be? 110 degrees. And then the same thing with 2 and 3. Would you agree those form a straight line? So then that means 2 has to be how much? 70 degrees. And so now you can see that the vertical angles have to be congruent. Okay? Any questions? Is that the last example in your notes for 1-4? Nope. All right, we have naming our vertical angles. Last example. So name the pairs of vertical angles. How many pairs of vertical angles are in the picture here? How many pairs? 2 pairs. So let's go with Hannah. Can you name 1 pair of vertical angles? Okay, angle LMK, which is this angle, and angle HMJ. Very good. Make sure you put those angle symbols in front. And let's go with Emily. Can you give me the other angle pair? Angle JMK and angle HML. Very good. Any questions about vertical angles? Complementary, supplementary, linear pair, or adjacent? All right, moving on to 1-5, and we've already brainstormed 1-5 over here on the board, so it'll go a little quicker. One thing, though, that I need to see if you remember, this book is also bad about, in other places, about expecting you to use something before it reminds you. And it's something you should have learned before geometry, but they don't review it always before. So does anybody know what the Pythagorean theorem is? What's the Pythagorean theorem? Go for it, Andrew. A squared plus B squared equals C squared. Write this down on your notes if you have forgotten. It is a theorem that you were already taught in middle school at some point, or last year if you learned it in Algebra 1 as a sophomore, whenever you learned the Pythagorean theorem. A squared plus B squared equals C squared. What is the shape that this is applied to? Okay, what kind of triangle? Right triangle. Pythagorean theorem only works for right triangles. If it's not a right triangle, you can't do the Pythagorean theorem. Which letter goes on this side across from the right angle? C. The other 2 sides would be the A and the B. Does it matter which one we call A or B? No. What is this side called that's across from the right angle? Hypotenuse. What are these sides called that are not the hypotenuse? It could be length or width if we're dealing with a rectangle. Usually in a triangle, we call them something else. Base and height if we're talking about area. That's later. Leg and leg. Have you guys heard them being called the legs of the right triangle? Okay, well, you can add that down. All right, so everybody has learned, though, a squared plus b squared equals c squared. So if I gave you a right triangle like this, and I said this is 3 and this is 4, and I asked you what is x, what would you write down on your paper? 3 squared plus 4 squared equals x squared. Okay, what is 3 squared? 9. What's 4 squared? 16, and that equals x squared, and it does equal how much? 25 equals x squared. So what's x? 5, because we take the square root of both sides. So x is 5. And if you've already had algebra 2, you may be going, wait a minute, it's not just 5, it's what? Plus or minus 5. But we're dealing with a measurement on a triangle. Can you have a negative side length? No. So it's only the positive part of that. Okay? Anybody not understand what I just did right there? Raise your hand. Stop me right now. Okay, because you might have to use Pythagorean theorem on your homework. They're going to assume that you know how to do that because you should have learned it before today. Okay, if not, come in and see me and I'll help you. So 1, 5, we're going to go through pretty quickly. I'm going to skip this spell work question and move on. So we're going to talk about perimeter, area, and circumference, and we already reviewed it all on the board over here. That's the basics of this lesson. Perimeter, we said, was the distance around the shape. The definition, that's not what we're going to use for our definition, but that's what it means. Circumference is special to what shape? Circles. And if you use the definition, the distance around, it would work for a circle. We wouldn't have to call it circumference. So that's why perimeter really isn't defined to be the distance around. Perimeter is defined to be the sum of the side lengths of the figure. But a circle doesn't have sides. So that's why it has a special name called the circumference, okay? So perimeter, you can think distance around, but you need to know the definition is the sum of the sides. Add all the sides together. Area, when we talk about area, what are we talking about? What's inside it. So when we talk about area, we're talking about the number of non-overlapping square units. That's huge because that means every time you give me an answer to area, you should have units squared. Inches squared, feet squared, miles squared. Your units, oops, I gotta change it back. Hold on one second. Gotta remember to do that every time. Okay, so you need to remember to put units squared. Here's my rule. Okay, if the problem doesn't give you units, I'm okay if you leave no units on the answer. So if there's not any units, you could put 81 and that could be your answer. Or you can write 81 units squared with a U, and that's fine too. But that is not the same as this. Okay, what does that mean? Okay, means 81 times 81, 81 squared. That is not how you write square units, even though the word square came out of your mouth first. You always put the units and then square the units. This means squaring the number. That is not correct, okay? Be careful because I see that every year. If they give you units, you have to include your units in your answer or you'll miss points every time. Okay, so if they tell you it's feet, you have to put your feet in your answer. Perimeter is just units. Area is units squared. If they give you feet, you can't put U for units. You have to tell me feet. Apply whatever's in your problem, okay? We already went over this on the board. It's in your notes right here, so I'm not going to re-go over that. Let's talk about base versus height. The base, is it good? Question? Okay. The base of a triangle can be any side of your triangle. Up here on the board, I went ahead and changed it to the bottom of my triangle, but it doesn't have to be the bottom. I can call A the base. If I do, the height has to go from the opposite vertex and it has to form a right angle or be perpendicular to the base. So this could be the base, and this could be the height. Think about it. If you turned it, it would look the same. Or this side could be the base, and then I would go from this vertex perpendicular and draw in the height. Does that make sense? So the definition for base of a triangle is it can be any side of the triangle. But height has to be the segment that goes from a vertex and forms a right angle with the line that contains the base. And this part right here is kind of wordy, so I'm going to explain that. The height has to go from the vertex perpendicular to whatever you're calling the base. But it says with the line containing the base. So here's an example. Let's say this is my base. First of all, what kind of triangle do I have there? It's obtuse. It's got a very big angle, so it's going to be called an obtuse triangle. If I look at this triangle and I call this the base, I'm supposed to go from this opposite vertex, and I'm supposed to draw the height perpendicular to the base. But you can't do that if you go over here to this little piece. So that's why they say that sometimes you have to extend out the base, and then your height ends up being outside your triangle, perpendicular to the line that would contain your base. So sometimes your pictures are going to show your height outside the triangle, but the triangle is still just this part. You guys seen pictures like that before? Okay. All right. So there's examples in your notes. I already said this, so I'm just going to skip that. Talks about units there. So now we're going to work some problems together. This one's super simple. I think you could do this without us even working it, so we'll just go really fast here. Find the perimeter. You can use a formula if you want to, or you can just add all your numbers together when it's simple like that. Perimeter, remember, was 2 length plus 2 width. What's the length? 6. What's the width? 4. And what do we get when we do 2 times 6 plus 2 times 4? 20. Be really careful with your math. 20, what are my units going to be? Inches. Inches squared? No, that's only if it's area. Make sure you put a P for perimeter, so if you have multiple answers on your paper, I know which one's perimeter, which one's area. So let's find the perimeter and area. Make sure you read your directions carefully. Area is going to be length times width. The length was what again? Width was? 6 times 4 is? And units are going to be inches squared. All right, I did that really fast because those were super simple. You should know how to do those, right? So let's throw in some algebra. Make things a little more fun here. Okay? So now they want us to find the perimeter of the figure, and we have some algebraic expressions. So again, it's a triangle. How do we find the perimeter of a triangle? Just, very good. Just add all the sides together, a plus b plus c. So let's start adding our sides. What do we have here? X plus 4 plus 6 plus 5x. Combine like terms. What do we have when we combine like terms? 6x plus 10. Now, just a reminder, if you have expressions on your picture, more than likely you're going to end up with expressions in your answer. We're not solving for x here. It did not say find the value of x. I'm not going to make you do this, so please don't listen to this and go, oh, this is what we have to do. But just a heads up, you know the Pythagorean theorem. Technically, since that's a right triangle, you could plug in those values to the Pythagorean theorem and have an equation that would solve for x. It's probably going to give you a quadratic equation and going to be a little more complicated. And at this point in chapter 1, that's not where I'm going. Okay, we will solve quadratics in this class. We will have to factor or use the quadratic formula or complete the square. You'll get to choose what you prefer versus Algebra 1 where you were tested on each one separately. But if it's got expressions, you're just going to have expressions in your answer. Are we good with that? Okay, area. What's the base of the triangle? 6. What's the height of the triangle? X plus 4. What's the area formula for a triangle? 1/2 base times height. So we have 1/2, you said the base was 6 and the height was x plus 4. I will also tell you that every formula that's on that board you're going to have to memorize and know for the test, okay? So any formulas that we learn you have to know. All right, let's simplify this. What's 1/2 of 6? 3. Make sure when you plug those values in that you put them in parentheses or you'll forget to do what? What's next? Distribute. So we have to distribute, and what do we get? 3x plus 12. So the area is 3x plus 12. Again, did they give me units in the picture anywhere? No, so I'm fine if you just leave them off because there's no units. Or if you prefer, you can write U for units and U units squared on area. Questions on this one? Okay. We're going to work several together just to make sure you're getting the ideas. We already talked about this on the board, so I'm just going to quickly point out what the definitions are, but you already knew these. The diameter is going to be the segment that passes through the center and has endpoints on the circle. So it passes through the center, has endpoints on the circle. That's the diameter. The radius is going to have to go from the center and has a point on the circle. So the radius starts at the center and has an endpoint on the circle. And then circumference, because perimeter is the sum of the sides, circumference is the distance around your circle. Questions on those words? Okay, I figured you guys were good with those. And then there's that picture that I drew on the board for you as well. And the formulas that we discussed about circles are up there too. Notice there's 2 circumference formulas. You can use either one. One is dealing with the diameter, one is using the radius. Most common confused formulas on the test. 2 pi r squared. Be careful. They both have a 2, they both have a pi, they both have an r. It's just where are you putting the 2 that makes all the difference. So don't mix those up. Okay, and like I said, we are not going to use 3.14. We are not going to use 22/7. If we round, we're going to use the pi button on the calculator and round after we've used the full value of pi. And I know teachers will say, or people will say, well, it's still not the full value because pi goes on how far? Forever. So the calculator isn't really using the full value of pi, but it's using more terms of pi than we would if we used 3.14 or 22/7. So we're going to use the pi button. But for now, we're going to practice that we're doing everything in terms of pi. And when you see in terms of pi, that simply means leave pi at the end of your answer. Don't go ahead and multiply that out. Simplify everything else, but don't plug pi in on your calculator. So this says find the circumference and area of a circle with a radius of 8 centimeters. So start with your formula. What formula do you want to use for circumference? 2 pi r. What's going to go in for r? 8. And then we're going to simplify that as much as we can without a calculator. So what could I simplify here? 2 times 8. What is 2 times 8? So we'll write our answer as 16 pi. What will our units be? Centimeters. So it says use the pi key on your calculator, round your answer to the nearest tenth. If your homework says that, I want you to grab a calculator and round it to the nearest tenth. Okay? You'll just type in 16 times pi, round to the nearest tenth. But practice leaving it in terms of pi before you do that, because on the test, I'm not going to give you a calculator. So all of the answers are going to be left in terms of pi. Okay? So practice simplifying before you type it into your calculator, but follow the directions on the homework. If it says round, that's what I'm going to grade, okay? Always treat pi like you would a variable until you plug it in. So you would never say x16, right? You would always say what? 16x. So you're not going to say pi 16. You're going to put the pi at the end, 16 pi. Treat it like a variable until you type it in. All right, area. What's the formula for area? Pi r squared. The radius we said was 8. So what's 8 squared? 64 pi, what are the units? Centimeters squared. Any questions there? Okay. I know we're going pretty quick, but I feel like you know most of that. Any questions on 1-5? One more time. Any questions about Pythagorean theorem that might catch you on the homework? You're still kind of not sure. Okay. On the homework, if you're dealing with money, what do you round to when you're dealing with money? Hundreds. So if you get a problem that's an application problem dealing with money, round appropriate to your problem. So if it's $50.21, but it's 0.2157 or 0.2123 or something like that, round to the hundreds to make it make sense to your problem, okay? All right, you have about 15 minutes miraculously today, not passing it out at the last second. It's amazing.